Today's lesson is going to look at how we use the pH scale. So first of all, when we're talking about pH, we're referring to the strength of an acid or basic solution. In an acidic solution, it would mean that the hydrogen ions are greater than the hydroxide ion concentration. A basic solution, we would have the reverse. The hydrogen ions would be less than the hydroxides, or we could say the hydroxides are greater. And we should mention that sometimes people use the term alkaline solution instead of basic. And lastly, we would have a neutral solution where the hydrogen ion concentration would be equal to that of the hydroxide ion concentration, such as we have in water. So pH, which stands for the power of the hydronium ion, and that power, we can think of it as strength, but it really has to do with 10 to a power, because the pH is based on a logarithmic scale. It comes from the constant ion product for water, because water is an amphoteric substance, meaning it can produce both hydrogen ions and hydroxide. And that ion constant product is equal to 1 times 10 to the minus 14. We're not going to worry about where that number comes from here in a Chem 1 class. We're simply going to utilize it. But before we do anything, we need to talk a little bit about what a logarithm is. A logarithm means that we're going to write any number in terms of 10 to a power. So if I take 100, which is 10 squared, the log of 100, you're simply going to tell someone what the exponent is equal to 2. That's all that a log means. 1,000, 10 cubed, the log of 1,000 would be 3. So clearly, the log of a number, say, such as 625, which is between 100 and 1,000, its log is going to be between 2 and 3. So we don't have to worry about using log tables or anything. You all have calculators, and we would find that the log of 625 would be 2.796. So let's make sure we know how to use our calculator to find the log of a number. Let's first look at the simpler calculator here. So if you are using this calculator in class, you're going to look and you see the log button up here. And what you want to recognize with this one is that first you will enter the number and then you will hit the log button. So for the example here, we would hit 3.0, then our EE button, then change sign, and then 4. Then we would finally hit the log, and we would get minus 3.523. So with the simpler calculator here, first you're hitting the number and then the log button. Let's look at the TI-84. For the TI-84, you're going to see that first you have to hit your log button over here. Then you're going to enter your number. So it would be your 3.0, then your EE button, which is the second function above your comma, then change your sign, and the 4. Closing your parentheses, you will see that you get the same answer. Let's find the log of this number. Right, so let's assume you're using this calculator. You would hit your log, then you're going to enter your number, and we put that in the calculator, and we will get negative 10.11. While we're looking at the calculators, let's look at the second function above your log key. Notice for both calculators that the second function above that is 10 to the x. A reminder, we said that the log is the value of x when we write that number as 10 to a power. So if our log is 2, what number are we talking about? This means we're taking the anti-log. So what we would do would plug in the 2, and now you're going to hit the second log so that you are performing this function, 10 to the x, and you see that we would have 100. We had used that example earlier. So if the log equals 2.4, what is the number? Or as many people say, what is the anti-log? That means you are going to enter 2.4 and now hit second, the log button, so that you're taking 10 to the x, and we get 251.19. Tomorrow during our Zoom session, we'll make sure all of you are able to do this, but please make sure you can figure this out on your calculator. We'd be hitting the 2.4, then the second, and then the log in order to get this answer. Let's find the anti-log of minus 3.5, and I'll talk about using this calculator here where we put the numbers in just in a different order than on the other one. So entering 3.5, then our plus minus, the second, then the log, so that we are getting the anti-log, the 10 to the x function. We would get what we see here, and if I write that as scientific notation, that would be 3.16 times 10 to the minus 4. Okay, if you're using your TI-84 Plus, you're going to hit the second log to get the 10 to the x function first, and then enter the number. That's the difference. All right, so now that we know how to use the calculator to find the log or an anti-log, we are ready to go back and indeed calculate pH. By definition, pH is the opposite of the log of the hydrogen ion concentration, where we can either write it as H plus or H3O plus. I'd just like to point out that this P represents a math function. It is always the opposite of the log of whatever we have written there. So in this case, the hydrogen ion concentration. But if I had something like pK, that would mean the opposite of the log of K. And we're going to see that we talk about pOH in a moment. Okay, tune in to the fact that we have to change the sign for pH. That's what we'll call here the sophomore mistake that many of you want to avoid forgetting to do that. As a result, if we calculate pHs for acidic solutions, we'll find the number is less than 7. Neutral solutions, it will equal 7. And for basic solutions, the pH will be greater than 7. And the pH scale goes from 0 to 14, again, because of the water ion constant value for water. pOH would mean the power of the hydroxide ion. So that would simply be the opposite of the log of the hydroxide ion concentration. And important to note that the sum of pH and pOH is always going to equal 14. So we're going to look at how we use these three equations, the two shown here, in addition to the pH equals minus the log of hydrogen ion concentration, and we can answer any question about calculating a pH. So our first example, they're asking us to find the pH given the hydrogen ion concentration. So the only thing we need to answer any of these questions are these three equations. This one, very straightforward. We can see that we are given the hydrogen ion concentration and we want pH. So our middle equation here is the only one that we will need. So pH will be the opposite of the log. We know the hydrogen ion concentration, so we are going to plug in 4.2 times 10 to the minus 10. Hydrogen ion concentration means molarity, which we were given here. Now it's simply using our calculator, and we find the log of 4.2 times 10 to the minus 10 using our calculator is negative 9.38, but don't forget we have to take the opposite of our log, and so the pH of this solution is 9.38. I will point out, because of the way logs are calculated, if we have 2 sig digs in our molarity, we always give one more in the pH calculation. In this example, we're being asked to find the pH, but notice this time you're given the hydroxide ion concentration. So even though I want pH, I can't use this equation directly. So I am going to easily be able to calculate pOH because I know the hydroxide ion concentration. Once I have that, I'll be able to utilize the first equation because the pH and the pOH have to add up to 14. So I want the opposite of the log of 4.0 times 10 to the minus 11. Put that in my calculator. I get negative 10.398. I want to change the sign, so pH is going to be 10.3 or 10.40 if we're rounding, right? We have not answered the question. They want the pH, but we know pH plus pOH is going to equal 14. So 14 minus 10.40 will equal 3.6, and this would be the pH of the solution. If I wanted to know if this was acidic or basic, careful that you are looking at your pH number. It is less than 7, so this would be an acid in this example. In our last example, we're being asked to find the hydrogen ion concentration given the pH. So we only need our one equation, pH equals minus the log of the hydrogen ion concentration. But notice we are solving for the H plus ion concentration. That means our equation would be 6.35 is the opposite of the log of X. What number? So we are looking to find the antilog. The thing here is to remember it is the opposite of it. So we want to use our calculator. We're really being asked to find what is 10 to the negative 6.35. That's what we're being asked to find on the calculator. So we're going to use the 10 to the x function. It's the second function above the log key. And when we put that in the calculator, we get a very, very small number. So you're going to put that in scientific notation. So I'm going to hit second. The scientific button is, or function is above the number 5. And that will equal 4.47 times 10 to the negative 7. Remember, it's concentration, so we're going to put capital M for molar. That would be the hydrogen ion concentration. All right, so we're going to do some practice in class tomorrow, making sure we can do these on our own.